Hello, everyone. Hopefully, everyone is doing well. Today, we are going to talk about production's possibilities frontier. So, we are going to define it to draw it in a graph. So, first of all, what is the production's possibilities frontier or production's possibilities curve? Some books call it PPC, some books call it PPF. So, the PPF is a graphical representation of all the combination of goods and services, goods and or services that can be produced by an entity. It could be an individual or a country or a firm in a given period of time. So it basically tells us that given the resources, what can we produce over a given period of time? So in order to draw that, we can use a model to understand it. So basically, what we need is, let's say we are studying, let's say USA. And so we simplify the model. We can't really look at all the goods and services that can be produced. So let's say there are just two goods. So in our model that we are devising, we have two goods that can be produced. So let's say good one is, we can call it corn, and good two is cars. Now, the next thing we need is, we need a resource. What is available for us to produce the good? So let's say we have one resource, which is labor hours. So we have some level of total quantity of labor available in the US. So the total labor hours available is, let's say 10,000 hours. Or let's make it a little bigger. Let's say 50,000 hours. So basically, the US has 50,000 hours available. And using these 50,000 hours, the US can produce either corn or cars or some combination corn and cars. Now, what we need is to figure out, how are these hours converted to corn and or cars? So for that, we need what we would call technology. So let's say that one corn requires, let's say, 10 hours to make. We can say, instead of one corn, let's call it 1 ton of corn. And cars requires, let's say, one car requires 500 hours to make. So then we have these two technologies available to us, and we are going to use that to produce either corn or car, or some combination of corn and cars, corns or and or cars, using all this 50,000 hours. Okay, so let's try to do that. Let's say we have now, so we have, let's say, hours for corn, production of corn, and then let's add a couple of more. Then we have hours for cars and production of cars. So we said we had, in our example above, we have 50,000 hours available. So now I can use, so this does not change. So this remains the same for the country. Now let's say initially I use all my resources to make corn, and I use 0 hours to make cars. So if I use all my resources to make corn, then if I wanted to make corn, and one corn requires, as we said, 10 hours to make, so then the total amount of corn I can make is 50,000 divided by 10, which is 5,000 tons of corn. So I can make a total of 5,000 tons of corn, and I would make 0 cars. Now let's say out of those 50,000 hours, I divide it up. I use 25,000 hours to make corn and 25,000 hours to make cars. So in that case, I would make, let's take cars first. So one car requires 500 hours to make, so it would be 25,000 hours available divided by the 500 hours that I have, so it would be 50. So I can produce 50 cars, and I would be able to produce 2,500 tons of corn. Now let's say I have 0 hours for corn and 50,000 hours for cars, then I can make 100 cars, and I would make 0 corn. So then this gives me my production, at least a table. I can add more combination of hours, but I mean, these 3 are enough. So let's now draw the graph. Let's move the graph down here so that we can see it. So I can put in the y-axis cars, in the x-axis corn, or I can flip them, that's fine. I don't need to have them in a specific way. So let's say I put cars down here and corn up here. So then, let me move this a little more to the right so I have space to write. So then I have, let's say, this is 1,000, 2,000, 3,000, 4,000, and 5,000. And cars I have, again, same idea. Probably let's try 25, 50, 75, 100. So I can see that if I produce 5,000 corn, then my production of cars will be 0. So then I can, that line would be, or that point would be up here. And then the next one would be 2,500 corn and 50. So 2,500 is somewhere here. 50 is somewhere here. And then finally, I have 100 cars and 0 corn, which is this point. So then when I join these lines together, this will be my PPF. So then this is now my PPF. So any point on the line is desirable. We call these points efficient. We call these points efficient because these points are using all the available resources, which is in our case 50,000 hours for production. Points outside the line, like here, here, and here, these points are currently unattainable. And the reason is these points, this is the maximum we can produce using the existing hours available. So any points outside is not available for us for production at this moment. Points inside, like these are, we can produce them, so these are attainable, but they are inefficient. Because we are not using all our hours available, we can actually either move this way or up here, and we can go up to the line to produce more goods or services. So this is how we would draw a PPF if given all the requirements that are like here. So these help us to produce the PPF up here. Now the other thing that the PPF helps us to do is calculate opportunity cost. Now if you need to understand what opportunity cost is or need a brush up of opportunity cost, you can watch my video on it. There's a link of it below. But opportunity cost, it is basically what we gave up to make our choice. And so the PPF helps us to calculate the opportunity cost. Now, the way we would do it is by using the slope. The slope here tells us what is the rate of change along the line. So if I'm on the line, let's say I am at this blue point, and I want to move over to this point, so from point A to point B, if I want to go this way, I need to give up the production of some cars in order to free up the labor hours in order to produce more of corn. So what we need here is the slope of the line. So basically we would do, so opportunity cost equals the rise over the run. Or I can also write it's the change in y divided by the change in x. Okay, so how would we do this? So in our case, it's easy because this is a straight line. So we can take these two endpoints, so 5,000 and 0. So my change in y is going to be 5,000 minus 0 divided by the change in x is going to be 0 minus 100. So this is my rise, this is my run. So that comes out to be 5,000 divided by 100, so minus 5,000 divided by 100, which comes out to be negative 50. So this tells us something really important. Let's move this down in the next line. So what this tells us is this number here, since the denominator is the number of cars production, it's telling us that if I give up the production of one car, I free up enough resources to produce 50 tons of corn. Or another way, an easier way to write it is the opportunity cost of one car is 50 tons of corn. So this is telling us what's the trade-off between these two products. So between a car and a corn, if I want basically one additional car, I have to give up 50 tons of corn. Or if I give up one car, I get 50 tons of corn. So this is what we have for production's possibilities curve. One last thing about production's possibilities curve, we've so far looked at straight lines, but it's not always going to be a straight line. Sometimes the line will be curved or bowed. So it may be like this shape. This is when the opportunity cost in the previous example, it was constant as we went along. In this case, the opportunity cost is not the same as we move from one point to another. So let's say this is going to be cars, or we can switch it and this is corn. Here, if we wanted to find the slope, we have to draw a line here and then use this line slope to estimate the slope here. And this will tell us the trade-off between cars and corn. So initially, if we're producing all cars, that means even the best farmers are producing all cars. So if I give up a little bit of production of cars, so let's say I move from here to here, I give up the production of this much cars, but I end up getting a lot of corn. So a little bit of car given up gives me a lot of corn. And then as we keep on going down the line, the opportunity cost changes. And then eventually when we're here, if I draw another line here, this gives us that, I need to give up then a lot more cars in order to get just a little bit, actually let's move this up here, a little bit extra corn. So opportunity cost in this case can change over time or over as we move along the line. And the slope would be drawing a tangent here and then finding the slope. But for now, we are just going to use this kind of production's possibilities curve and find the opportunity cost of this straight line. Hopefully this was beneficial, and I will see you at a later video. Have a good day.